Hello and welcome to Calc BC channel. This is your host. You know who I am. So we're just going to get started. We're going to be talking about parametric equations. Parametric equations, a little introduction into that. Until now, we have been representing a graph with a single equation involving two variables. You know what the variables are, x and y. But now we are going to start to study situations where three variables are used to represent a curve in a plane. So for example, we're used to seeing things like this. And that is called a rectangular equation to represent the path of an object that is propelled into the air at an angle of 45 degrees. Okay? This tells us where the object has been, but doesn't tell us when the object was at a certain point x, y. And that's what parametrics are going to do for us. So that's why we're going to have to introduce a variable, new variable, t, called a parameter. That's where you get parametric from. So a parameter, and it's going to be this variable t. We can write this function, both x and y, as functions of t. So we can write this as x equals 24 times the square root of 2 times t. And the y part is negative 16t squared plus 24 times the square root of 2t. These are the parametric equations. We will learn a little bit later about how to find them, but right now just understand that these are two parametric equations. Three variables, x, y, and t. So from this set of equations, you can determine that at a time t equals 0, the object is at a point 0, 0. So when t is equal to 0, we have 0, 0. That's where the object is. If at time t equal 1, we can figure out that the object is at the point 24 square root of 2, 24 times the square root of 2, minus 16. That is the location at t equal 1. For this particular motion problem dealing with this, x and y are continuous functions of t, and the resulting path is called a plane curve. So the resulting path, so we have and we'll explain a little bit later how to do this, but this is where we end up with a plane curve. This is at 1 second. This was at 0. This is when 0, 0 here. And this is at 1. We have those points that we found before. 24 root 2. 24 root 2 minus 16. There's a direction to this. This is the object being launched at angle 45 degrees. Here we go. And this is called a plane curve. So I'm going to just pause for a second, or I'm going to let you pause for a second to get the definition of a plane curve. If you want to pause the video so you can write this down, so you can read it. I'm not going to read everything to you. I think you can easily read it. Moving on, we want to sketch a curve. So how are we going to sketch a curve? Okay. We're going to have to worry about sketching this curve and using some values here. So I'm going to put some t values in. T equal negative 2, negative 1, 0, 1, 2, and 3. We can do more if we want, but that's good enough. We're going to evaluate both x and y with these t values. So in doing so, you will get the result for x. You'll get 0. Plug in negative 1, you'll get negative 3, negative 4, negative 3, 0, and 5. And for y, we will get the values negative 1, negative 1/2, 0, 1/2, 1, and 3/2. And we got those values from plugging our t values into both this equation and this equation, parametric equations. Now when we plot those, we're going to plot them on here. Make this 2, this 4, this 6. Make this 2, this 4, and then the negatives over here. And then down here the negatives. So we plot this, negative 2, 0, negative 1. So right here, bright green. Here we go. And then the next one, t is -1, we have -3. That's 2. So right here, -1/2. So it'll be like right here. And then when t is 0, we have -4, 0. So if you look, our pathway is like this. So we have kind of a direction to it. So it looks like it's going to be kind of going around. Now this is parabolic, so you would kind of think of it as being a parabola like that. So the next one, -3, and then +1/2. 0, 1, 3, 3/2. So you get kind of a feel that it's going to look like this. I know what you're barking right away, with some directional, some arrows showing kind of where it is, and this is kind of important there. That hey, this is not a function. Well, that's the cool thing about parametrics. It gives us a flexibility to graph things that necessarily be represented by more general than just graphs of functions. So how to graph that? You see I put arrows on there because it's going in that direction like that. So now, what if we want to eliminate this parameter? What if we want to turn it back into a rectangular equation? What if we have these parametric and we want to be able to do some things with it? So we're going to learn how to eliminate the parameter. And we're going to eliminate that. Easy steps. We have our parametric equations. We want to solve for t in one of the equations. So let's pick the easier one to solve for t. We'll do right here. So we're going to solve for t. Alright. Then we're going to substitute this into the other equation. So you'll see already, okay, so we have, now this is our 2y, so we're going to say 2y squared minus 4. And when we simplify that, we get our rectangular equation. So there's our rectangular equation from our two parametric equations. Now if you were to try to graph that, you couldn't, because it's, as you can see, not a function as you would see it to be. But you would graph it. You would see some shape like this on a graphing calculator. Now you might say, all right, well, I have to solve for y and take the square root. Right, you know you get the top of it. That's why you do plus or minus to get the bottom as well. So let's take another look at eliminating the parameter. So we have two functions here. Two parametric equations. And we want to eliminate the parameter. So you might want to pause the video here, try and see if you can follow the steps back here. Okay, solve for t in one of them, plug it into the other, boom. If you can do it. And then come back and listen to the video when you're done. So the first thing I'm going to do is I'm going to look at this guy. And I'm going to square both sides to get rid of this radical here. So I'm going to get x squared equals 1 over t plus 1. Okay. And then the long of it is multiply both sides by t plus 1, multiply by t plus 1, and then divide by x squared. But I'm going to end up with, when I do that, t plus 1 equals 1 over x squared. And then solve for t. We're just going to get t is 1 over x squared minus 1. Alright. Now we want to substitute this into the other guy. Now we could also simplify this. If I wanted to simplify, you get common denominators here of x squared. And we end up getting 1 over x squared, 1 minus x squared, over x squared. So now take this and we're going to plug it into t for the other guy. So we're going to plug it in here. So we have y equals, we're going to have 1 minus x squared over x squared. And then again, 1 minus x squared plus 1. Whoops, over x squared. Now we can do some simplification here. Get common denominators yet again. And when I get common denominators here, what's going to happen? This is going to become, I'm going to erase it. This is going to become x squared over x squared. Okay. And then what's going to happen is, when I combine this together under 1 over 1 denominator, you're going to see that. And then you're going to see that this and this, what's going to happen to that? It's going to go goodbye-bye. And then we're going to multiply by this reciprocal. Or when you divide by fraction, multiply by the reciprocal. So then this will go away. and y will equal 1 minus x squared is our rectangular equation. It's defined for all values of x, but from the parametric equation for x, you can see that the curve is defined for only t greater than -1. This implies that you should restrict the domain of x to positive values, as shown right here. This is the parametric equation. This is the graph of it. Okay? The direction would be going this way, and this is what I use to graph this parametric equation. Now, don't worry about this and this, because that's turned off. But I just graphed the parametric equation as I saw it there, x and y, x1 sub t, or x sub 1t, and y sub 1t. And then if I were to graph it in function mode, it would look very similar to that, except with an open hole right there. Alright, so that's just overcap of what it is. What a parametric equation is, this third variable, introducing this third variable t. If we go back, the definition of a plane curve, sketching that curve using that parameter t, eliminating and turning it back into a parametric equation. I'm sorry, from a parametric to a rectangular. Then another one, but now talking about dealing with the domain of it. And in our next one, you'll see, video 2, you'll see that we're going to be using trigonometry to eliminate the parameter, and then move on to a little bit of calculus. So hopefully you enjoyed this and were able to follow along, and we'll see you on the next video.